Now we're going to be doing two-sum. So let's have a look here. Given an array of integers nums and an integer target, return the indices I and j such that nums I plus nums j is equal to target and I is not equal to j. You may assume that every input has exactly one pair of indices ij that satisfy the condition. Return the answer of the smaller index first. Basically, what it's saying is that if you have an array, right? I'm just going to use this example. 4, 5, 6. Right? We want to return two indices. So this is index 0, this is index 1, index 2, right? The two indices I and j such that when you add up their numbers, when you add up the elements on that index, it's going to equate to target. Say the target here is 10. So as we can see here, the nums I and nums j that matches this criteria is 4 and 6, right? 4 and 6. You add them up, you get 10. And then you want to return their indices. So the answer is going to be 0, 2. This is what we're going to return. So how do we do this? How are we going to solve this problem? Let's have a look at a solution you might cook up on your own. At least at first glance, the naive solution, you would say. Let's say we have nums, and it's the same as example 1, okay? 3, 4, 5, 6. I'm going to do a little modification, and I'm going to say that the target is going to be 11. Let's say these are the parameters that we got put in. So probably the most straightforward solution is to do a nested for loop, right? You do a for I in, I don't know, like length and range, length of nums, and then you do another for loop, right? For j in range, 1 length nums, something like this. So what this is going to do is you're going to go, okay, you're going to say I is like here. So j is going to start here, right? We're going to go, okay, are these two, do they add up to 11? No, they don't add up to 11. So you increment j, and j comes over here. You go, do these add up to 11? Nope. Then you increment j, do these add up to 11? Nope, they add up to 9. So that doesn't work either. And after that, you start incrementing I, and then you check I with, and j gets moved up here. You go, hey, do these add up to 11? Nope. Do these add up to 11? Nope. You can see that we are doing a lot of we're doing a lot of trial and error here. We're testing every possible solution, the brute force solution, basically. And then we go to the last pair where we have I and j here, this and this, and then we find out that, hey, they do add up to 11. It's 5 and 6. Now, nested for loops like this, we're basically checking every element with every other element. We're checking 3 with all of this. We're checking 4 with all of this. And actually, from the 3 loop, we've already checked it with 3. And 5, we're checking with every other number. 6, we're checking with every other number. So this is actually, if you think about it, time complexity of this, for every element n, where we have to check this element with every other element. So it's n times n, aka n squared. Usually with n squared solutions, so this would be the time complexity. It's not ideal. It's really not ideal. We'd probably prefer something a little bit faster, yeah, than the brute force solution. So why don't we try a different approach? What if we knew what we wanted, what pair we wanted, right? So let's say we are looping through nums. We first encounter 3. Right? So if we have 3 and we know that the target is 11, then we know that the number that we want is 8. The pair to 3 is 8. If we've seen an 8 before in the past, then we also know its index, so we can return that. Okay? This doesn't really super make, it might not super make sense right now, but bear with me for a moment. So if we go 4, we're looking for 7. Unfortunately, at this point in time, we've only seen a 3 and a 4. So there is no 7. It doesn't exist yet. We don't know. We've not seen a 7, okay? But we have seen a 3 and a 4, okay? No problem. Let's move on to a 5. At 5, we're looking for a 6. Oh, we know there's a 6 here. We can see that there's a 6 here. But the computer at this point in time have only seen 3, 4, 5. So as far as it's concerned, there is no 6 yet. So, okay, no problem. We can move on to the next one. And then 6, okay, at 6 we are looking for a 5 to add up to 11. Oh, we've actually seen a 5 already. And then we can get the index of that and the index of this, and then wha-bam, and that's going to be the answer. So that's kind of the goal that we want. We want something like that. Now, if you think about it, each time we encounter a new number, we want to check whether the pair that we want, so in this case it's 8, 7, 6, etc., if we've seen that pair before. So having this kind of instant lookup where you know the key is most suitable for a dictionary or a hash map. So to construct this, let's give it a try. Let's give hash maps a try, okay? So let's see. So if we have a hash map, the key value would be the number, and then the value would be the index. Because we want to grab the index for the final answer. Let's have a look at how this is going to work. So I'm going to delete these arrows real quick. So let's say we start at 3. Okay, at 3. Okay. First of all, our dictionary is empty. Completely empty, nothing inside. So when we encounter 3, we are saying, hey, do we have an 8 inside of this? So we check, is 8 in this dict? Well, it's not because it's empty. Okay, no problem. We don't have our pair yet, but I'm going to make a memo that I have seen the number 3 at the index or at the position or the index 0. We've seen 3 at 0. So in the future, if we so happen to encounter an 8 somewhere here, we know that we've seen the pair of 8, which is 3, right? And we keep repeating this. So with 4, we're looking for a 7. There is no 7 in the dict. No worry. I'm going to make a memo of it for future use if we do end up finding a pair. Now for 5, same thing. We're looking for a 6. We're looking for a 6 here, and there is no 6 inside this dict, so that's okay. We'll make a memo that we've seen a 5 at 2. Now this is the interesting part. Once we get to this number, once we get to a 6, we're looking for 5, right? Because 6 plus 5 equals 11, right? So we're looking for 5. There is a 5, actually. We did find a match. There you go. We got a 5, a 2. And at this point, we know that we've seen a 6 at 3. So we can return 2, 3. And that's the solution. Okay. So to put it a little bit more formally, when you make this lookup of the pair, you want to find the pair. The pair is actually going to be the nums at I, which are these numbers. Oh, sorry. The pair is going to be the target minus the nums I, right? So this is the formula that we're going to use to calculate to find the pair. And once we have the pair, we're going to look it up in the dictionary, which is going to be one time. Because that's just how hash maps work. They're fast and efficient for lookups when you know the exact key. Well, all right then, let's try coding this up. First of all, we kind of want to set to keep track of all the elements that we've seen before, right? So we're going to say scene. We're going to create a dictionary. I'm going to call it scene. And then the next step is we want to loop through each element of nums for I in range length of nums. Okay. For every element in nums, well, at least technically it's every index in nums, we want to check. We want to first find out what the pair is. What are we actually looking for? The pair is going to be target minus nums I, right? That's what we agreed upon before. Now that we have the pair, I want to check if I've seen this pair before. Okay, so if pair in scene, okay, which means, wow, we've seen it. You've seen the pair, we've found the answer. We can return, well, it's going to be an array of 2 elements, where the first element is going to be the index of the pair. Okay, so we know that the key in the scene is the index. So we grab the index of the pair, like so. And then we also want the index of the current number that we're looking at, which is I. Okay. Otherwise, we have not seen the pair yet. And so we want to record our current number and index, and we put it into the scene dictionary in case we find the pair number in the future. Let's do that. So we go scene, nums I equals I. And that's it. The code. Yeah, there we go. Right, that's a pretty simple solution. Okay, bye.